Welcome everyone. I'm very happy to start this session, which is dedicated to improve forest management. We are going to talk about MRV, to economics around improve forest management projects. And to start, I think we will all feel more comfortable with the forest in the background rather than a wheat crop field, because most of us are interested to forests. So let me introduce myself. I'm Simon Martel. I work for I4C, the Institute for Climate Economics. We are a French-based think tank, an independent organization providing independent policy analysis on both mitigation and adaptation climate change policies. I have a background in forestry, and we have been working on carbon certification for 15 years at I4C. We prepared this session with Climate Kick together, and I had the privilege to be part of previous carbon farming summit. 2 years ago, I noticed that there were no sessions dedicated to forestry in Valencia. Last year, we had one session which was a great success on forestry, so dedicated to forestry. And this year, we can notice that there are 5 sessions with forestry in the title, which also show the momentum on the subject of carbon and forestry. So I'm just going to give you a few words of the general context and to give the objective of the session, and then I'm going to present the schedule for this session. The general context is that we have in Europe European carbon sink which is around 200 million tons of CO2 per year now, and our target is of 310 million tons of CO2 for 2030. So we have a real challenge to reach this target, which is almost impossible now. There are various levers to reach this sink target, and among these various levers, the improved forest management one is one that in theory has a great potential. The European Scientific Advisory Board for Climate Change say that it's among the few practices that could deliver significant short-term removal at a relatively low cost, which is something important. On the other hand, forests are already suffering from climate change. The EU carbon sink has already decreased by 30% over the last 10 years. In some countries, it's even worse. And this decline was not predictable, and we can't predict the future of this sink. So it's a great challenge to find a way to store more carbon in the forest while knowing that this carbon sink is also going to suffer. So that's why improved forest management practices are very important, and that we are going to discuss this point to, in one hand, to meet the needs for forest adaptation for forest practitioners, and also to enable us to achieve our mitigation goals. So the objective today is to illustrate the diversity of improved forest management across Europe, to highlight what has already been implemented in Europe, and we are going to have a good example of that, to explore some innovation, for example, for MRV systems that are well adapted for such projects, and to discuss together enabling conditions and also barriers for this kind of project. This is the agenda of the session. So we have the chance to have different speakers coming from different European countries and representing different types of forestry contexts in Europe. with different backgrounds. They will give short presentation, 7 minutes for each of them, and then we are going to have a panel discussion, and at the end we keep between 20 and 30 minutes for an interaction with you, taking your question, comments, and so on. So I'm going to give a first presentation. I will try to be brief, to give some recommendation coming from a European project, the Informa project, which was conducted research during the last years on bringing sustainable forest practices to store more carbon in forests. But first, let's define what is improved forest management. IFM projects are implementing in forests, which are already forests and which are remaining forests. That's something important. So basically, you implement practices that allow you to have more carbon a few years later, and not more carbon than the first stage, but also more carbon than a baseline, which is basically what would have happened without the project. We can categorize practices in different parts. There are conservation-like practices, management practices, and de-risking practices, but I'm going to come back to that later. This session is especially, we would like to give some insights to bring some food for thought for the development of the CRCF IFM methodology. So before to give in the technical parts, just a few words on where do we stand on CRCF and forest. We are going to speak only on the forest removals. Carbon storage in wood products are another methodology under the CRCF, basically in the carbon storage in buildings methodology. And to go very quickly on the timeline on the CRCF, so on the top here you have the general timeline, and on the bottom some dates for forestry. So there is an afforestation methodology that is going to be published this year. There was a public consultation in February, and normally this methodology is going to be published this summer, around this summer. And the work has started to build an improved forest management methodology. It has just started, so there will be developments all along the year to build this methodology. We already know some features for forest methodology. So basically, in the afforestation methodology, one important criteria is that we have temporary credits, and that the temporary credits for the afforestation methodology are defined for the moment for 40 years. That has to be confirmed, but that's important to have that in mind. Quickly, some results that we had in the Informa project based on a review on 15 existing IFM methodology. We went to different standards across the world to see what were the criteria in this methodology. Some challenge that we have noticed is that the first one is that there were a diverse range of practices behind the word of IFM. But in most international methodology, the focus was on reducing the harvest, either by postponing harvests or by implementing set-aside areas, for example. And in Europe, we also need to produce wood, so we need to find other way, complementary way to implement IFM practices. So our recommendation is to have a really diverse range of practices which also fit with the context, with the different European context, and to build methodologies that are really backed by science to demonstrate a real carbon impact. Then one important point was that the baseline were the core of different weaknesses and that have been very important for the different loopholes in recent carbon offset scandals. So to focus on baseline and to limit the choice given to project developer is something important, just to limit information asymmetry, which could be also to be okay to have some local data, but this data need to be independent. One recommendation was to explore the use of dynamic baseline and to avoid to choose baselines that fit with real conditions. And then there were questions on the impact on climate change on forests and on the different buffer and the amount of credits that are put in the buffers. But with the CRCF, we have both a buffer system, but also the system of the temporary credits, which with these two systems, we should tackle this problem. Very quickly, some development on assessing different innovation. So colleagues from KU Leuven has conducted research on some innovation for carbon project. A first very brief result was that remote sensing was great to reasonably estimate accurate estimate in total forest carbon stocks. But to differentiate between two different management practices, it was not so easy to detect small difference. So a lot of improvement is made in remote sensing, but today it's not so easy to use it for carbon project measurement. That's why in the project, an assessment was made on a field app, which is basically a LIDAR-based app to measure DBH, height, and to determine the species. It has been compared with conventional measure in the field, and the results were quite promising. The accuracy was quite good, and this app allowed to save to go 3 times faster than with conventional measurement in the plot. And one conclusion was that this app was already important for data consistency. So that's an innovation that can be used for MRV in IFM projects. And very quickly, colleagues have been assessing dynamic baseline, so basically looking at the feasibility to use the Vera dynamic baseline in Europe, assessing the different national forest inventory system. And to be very quick, there are some constraints and some barriers to effectively use this dynamic baseline. Just to conclude, and to give you takeaway messages, a lot of practices for IFM in Europe. That's an important point. Innovation is key for the MRV to lower the administrative burden, but we don't see one size-fits-all solution, so we need to combine approaches and to tailor these approaches to different contexts in Europe. Baseline are key, I already said that. And the long time scale in forestry is something very important as well, with a lot of uncertainty, and that's somehow a unique case in the European carbon farming context, and that's a case that we need to discuss also for economic questions. I'm not going to take more time, but I'm just going to introduce the next speaker with Swazik Figer. Swazik is coming from France. She is a forest engineer at the National Center for Forest Ownership, the CNPF. She specialized in forest carbon research and modeling, and in the past she has been working in a research center developing a model on forest growth under climate change. Thank you very much, Swazik, and the floor is yours.
Thank you, Simon. Hello, everyone. So the presentation I'm giving today is about some results of a joint project between the French National Center for Forest Ownership, the French National Forest Office, our National Institute for Environmental and Agricultural Research, and the Institute for Climate Economics. So just to get started, a bit of context. France has its own voluntary carbon standard, which is called the Label Bas Carbone. It was launched in 2019, so 6 years ago, and it's currently mainly driven by forest activities. So roughly half of the credits in the standard are from forest activities, and it represents around 4.7 million TCO2 right now. Our most ancient methodologies are afforestation and reforestation. They have already undergone few upgrades. Can you hear me? Okay. A few upgrades since 2019. And the newest methodologies are improved forest management. And like, for example, the most recent one is about rotation extension. And we have a few more coming up. So especially the first one, enrichment planting, which is the one we are going to talk about today. So currently, we have a methodology to address stand loss due to natural perturbation, like a windstorm, wildfires, pest outbreaks. So this is covered in the standard. But what happens if you want to act before the loss of the stand due to climate change? So the issue is that we currently have healthy juvenile stands that are deemed highly vulnerable to climate change. These are results from models, but also recent observation, like the spruce crisis we have in the east of France. And the other issue is the unplanned cost of adaptation for the forest owner and the forest manager. So the aim of this new methodology is to anticipate and finance this, the poor adaptation of naturally regenerating forests, to develop a technical framework and a financial incentive for enrichment planting, and to promote mixed species stands to increase resilience and ensure long-term wood production. And another idea behind this methodology is to address the growing demand from the public for alternatives to the clear felling and replanting model that prevails in managed forest in France for now. So in this methodology, enrichment planting is defined as a low-density plantation with a more resilient species into a natural regeneration which is deemed vulnerable to climate change. So the idea is that you have your plots covered with natural regenerations, and you clear up some patches to introduce a more resilient species. There is a wide range of scenarios, but these are oversimplified schemes. So either you end up with a mixed stand with your original species and the enrichment species, and the forest cover is maintained, and this is the best case scenario. But the worst case scenarios would be that there is a complete dieback in the natural the original species, and only the enrichment species remains. So moving on to the baseline scenario that is opposed to the project scenario, we had a bit of trouble to define these scenarios, because we had a few options. So the first one is you are not happy with the initial species, it is not adapted, you worry that it's gonna experience high mortality rate in the future, so as a forest manager you remove it and you plant another species that is better suited. So to us it's the less plausible scenario due to prior investment. Natural regeneration require long-term thinking way before, already? Way before the, it's going fast. Way before the final cut. We're talking about 20 years. So the other option, which is the most conservative one, is that we put no assumptions on mortality pattern due to climate change, and we assume in the baseline scenario that you end up with a healthy stand with no impact of climate change. And the most realistic one is that due to climate change, you experience high mortality rates, but in modeling, it requires many strong assumptions, and we are not sure of which one is the good one. So speaking of modeling, the model we used, it was developed by INRAE, and we used it because it predicts the dynamic of mixed stands. It is calibrated using national forest inventory data, and it implements realistic management strategies that have been developed by forest management experts from the National Forest Office, so it is very grounded in reality. I'm sorry, I'm going very fast. So we oppose the vulnerable species, so we chose 6 species for now that are eligible. And we defined default vulnerability area that were drawn using a combination of climate compatibility model and present data. And we selected the enrichment species based on a few traits. The idea that you can keep is that it has to be growing faster than the original species, and it has to be more resilient to climate change. And okay. So as you may have guessed now, this methodology is not delivering a lot of carbon credit due to the very conservative baseline. So we have decided to develop a hybrid carbon crediting system. So we use ex-ante credit that are delivered after the first verification. It's a very, very low emitted volume, but it's meant to enhance the attractiveness of the project. And it's solely based on model predictions. And we add to this exposed credits after a second verification, and then there is a potentially higher volume emitted because we revise the baseline to take into account the mortality that we cannot model. So there is no assumption. The reality is that there is dieback, so we can lower the baseline. Yeah. And in the label bas carbone, it's an innovation because it's mainly issuing ex-ante credits for now. So this is one of the first time we're going ex post with this methodology. And a few messages to take home with you. So this methodology is the culmination of 3 years of work with experts from forest research, field management, and carbon market and policies. The carbon calculations rank among the most advanced in forest carbon methodologies because they rely on a robust peer-reviewed forest growth model that has been calibrated with forest inventory data local to the project area. It is designed to predict pure and mixed stand productivity. So there is a mixture effect in the model, and it allows us to incorporate very realistic management scenarios. And this methodology is a no-regret measure, and it's scalable across Europe, we think.
Thank you very much, Swazik. It was very interesting. I'm sure you have a lot of questions, but please keep them for later. The next speaker is Vincent Furstenberg. Vincent is an Austrian forest scientist and practitioner. He's specialized in forest-based carbon projects and climate adaptation. He's the CEO and the co-founder of ECS Climate Solution, and today his work focuses on developing precise and realistic baseline to generate high-quality carbon removals. So please, Vincent, the floor is yours.
Perfect. I'm not going to stand there because it will lead me to talk freely and then time is just gone immediately, so I will stick to my notes. Today I will briefly present the ECS methodology for carbon removals through climate resilient forest transformation in managed forests. So we're talking about managed forests in Austria, meaning that the average size of our projects is roughly between 500 and 5,000 hectares. So we're talking about existing forests, incredibly valuable ecosystems under enormous pressure. And that means that we have to first and foremost preserve them, and in order to do that, we have to change them. So our aim is to increase resilient carbon stocks by at the same time supporting climate adaptation and biodiversity. We will talk about some of these points later in more detail, but the main goal was to use the precise project-specific data that we have in Austria and the neighboring countries, and at the same time to use a highly standardized process for the baselining to minimize the possibilities of manipulation for each project-based carbon project. As we are working with existing forests, climate stability, calamities, climate stability analysis, these are core elements of the methodology. So if we want to change forests, we have to understand their pain points. And the future stability of tree species in our system is evaluated in high spatial resolution by using national climate models, as you can see on the right. These climate models are using parameters like soil, altitude, exposition, geology, etc. And they give us the conditions for each species under a certain climate scenario. So on the right you can see the spruce conditions from 2036 to 2065. Based on this analysis, the tree species are categorized into climate stable, climate resilient, so to say, and climate unstable management groups. So as you can imagine, spruce, for example, in the dark green areas of this map has to be treated in a different way than in the yellow areas. Also for the baseline, baseline is the core of each good methodology. A standardized algorithm determines an objective rotation period for each tree species. That's the first step. This calculation combines traditional forest harvest calculations and climate persistence of species. The result is an objective harvesting volume per tree species, combined with the conservative growth tables, the public Austrian growth tables, that underestimate growth usually by 10 to 20%. This defines the baseline carbon dynamics of each tree species in the forest. This can be a rising baseline, this can be a falling baseline. It's very individual per forest, per tree species. And the total makes the baseline carbon dynamics of the forest. So now that we know how the baseline is moving, the project line is where it's getting, of course, more interesting. The project line goes beyond the baseline. Together with the forest owner, we develop a carbon management concept tailored for the specific forest. The strategy focuses mainly on reducing vulnerable species and structures, which means this costs us carbon. We have to reduce the carbon in those segments, but we have to do that to make it a good project and to increase the resilience of the forest. At the same time, we want to increase the stocks of the climate resilient species, and we want to promote biodiversity relevant habitats, ecologically valuable species. And the result is a net increase, not only in carbon, but in resilient carbon stocks. Everybody working with diverse and especially closer to nature forests knows the current limits of remote sensing in these multi-layered forests. So for MRV, we are using existing high-quality data streams that are already in place in countries like in Austria, for example. So that means in between our classic inventory cycles that are high detailed on the ground full inventories. We use existing third-party, mainly government-reviewed data streams as harvesting reports, calamity reports, etc. This allows a reliable ex-post year-by-year monitoring of the carbon flows of the forest. And together with the conservative growth that we know for the next 10 years, we can monitor and document and certify the change in carbon stocks. And here in the end, you see on the lower left a baseline scenario. This is a forest that is losing carbon, which is a very good example because most forests in Austria are losing carbon right now. The lower bit, the light green, is climate vulnerable conifers, for example, spruce. And you see that in the baseline scenario, they're slightly losing carbon in that segment, but it's pretty stable. Whereas the forest is losing carbon in the mid and dark green section, which are the climate stable conifers and climate stable broadleaf trees. They're gaining, it looks like it's gaining a little bit of climate vulnerable broadleaf trees, and it's losing a lot of the biodiversity species. Whereas with our change management, we achieve that, first of all, the light green's volume, the light green climate vulnerable conifers, they get decreased. That costs us carbon, as I mentioned. So we have to swallow that basically and lose credits from that, or credit potential. But at the same time, we manage to increase the volume of the stable segments, stable broadleaf trees and conifers. And we manage to increase the biodiversity species by quite a lot. So in the end, as you can see, it's not a huge difference in total carbon, but it's a difference on the composition and the resilience of the forest. So in the end, the outcome is roughly 1 ton per hectare per year. But what we really want to achieve is to make the forest more resilient. So in summary, the ECS methodology combines robust forest inventory data, climate-informed management, and transparent monitoring to generate smart, climate-resilient carbon removals, as it is necessary in existing managed forests. Because everything else would be a risk both for the buyers and the landowners, and we want to avoid that at all costs. Thank you very much.
Thank you very much, Vincent. So with Swazik and Vincent, we had 2 good examples of existing projects and methodology that are implementing resilient forest management. Now we are going to switch to some economic questions. The next speaker is Martina Agosta. Martina has a PhD in agricultural and forestry economics. She's working as a junior researcher at the Council for Research in Agriculture and Analysis of Agricultural Economics here in Italy. And she's in particular a member of the Forest Observatory at CREA. Martina, please.
Okay. Well, good morning, everyone. And today I will present you research design about the assessment of feasibility, economic feasibility on forest carbon credits project. Unfortunately, we have not data yet for applying this methodology, but we are collecting data. And to begin with, it is necessary underline that only recently the National Registry for Forest Carbon Credit was approved in Italy, and it is waiting for the activation, for its activation from the ministry. Instead, the agricultural section for agricultural registry is still in consultation at the ministry, the Italian ministry. The forestry register will be contained into the National Agricultural Information System, and this is the result of a growing interest to this topic, and for this reason there is the need to develop a tool for helping entrepreneurs to make economic decisions about this kind of investment. For this reason, we developed 3 research questions, and the first one is related to the type of production, the type of product. So, is it more profitable to continue sell timber or sell carbon credit? And to answer this research question, we are collecting data, as I said before, and we developed in particular a survey, a questionnaire, to be submitted to forestry and agricultural entrepreneurs who intend to undertake afforestation, or afforestation or reforestation projects on bare soil, or who intend to adopt a sustainable forest management on their forested areas. And in this questionnaire, we included several economic and financial questions with objective to rebuild the balance sheet of these companies. More in detail, the methodology is the cost-benefit analysis and the cash flow analysis. It is a cash flow analysis because we will rebuild the entire lifetime of the investment, and hypothesizing 3 different timelines, 20 years, 30 years, and 50 years, because we guess that different timeline on the investment can have a different effect on economic return of this type of investment. But we don't know. And we will consider benefits in terms of revenues, timber and or carbon credits, which are the main product from this type of investment, and the cost. And we will have 2 main items of cost item. The initial capital expenditure, called CAPEX, that are the cost for starting the project, no? And the operating expenditure that represents the yearly operating for instance, for the maintenance or for silviculture operation. And in this slide, we reported the financial indicator useful to assess if the performance of this investment, if a project is effectively cost-effective or not. And in particular, the most important is the net present value that represents the actual economic value of the investment. And the second one is the discount benefits cost ratio, that is a ratio between the actual benefits and the cost and the actual cost. More in detail, if net present value is positive, and if discount benefits cost ratio is greater than 1, so it means that with a high probability, the investment will be economically viable. And the last one is a very useful index. It is the payback period that expresses the time needed in terms of year to recover the initial capital expenditure. That are the other 2 research questions. In particular, what is the minimum size in terms of surface area, and which is the minimum carbon credit prices needed to ensure the sustainability of the project. And to find these two values, called A star and P star, we will apply, sorry for the formulas, and we will apply the inverse formula of MPB, in order to find the break-even point. The break-even point, as illustrated in the graph, is in the figure. The break-even point is the point where NPV, net present value, is equal to 0, and where revenues are equal to total cost. In conclusion, our objective is provide a tool for helping entrepreneurs to have a clearer view about the economic return of this investment for help them to make a reasonable decision about this carbon credit investment. And thank you.
Thank you very much, Martina. So after France, Austria, Italy, we are going to Finland. Our next speaker is Ville Jetalahti. Sorry if I mispronounce your name. Yeah. So Ville is a business advisor at LULUCF, which is a natural resource institute in Finland. He's driving the commercialization of digital forest carbon twin technology. He brings with him 2 decades of work as a senior executive at Stora Enso, that you may all know, and has taken several group functions under finance and strategy. Ville, floor is yours.
How are we on time? Just want to check that. All right, good. Great to be here today. Happy to see that improved forest management is attracting a good level of interest in the participants. So I will first touch on the topic of the challenges around improved forest management, and as Simon pointed out, and I think also the previous speakers, it is a different ball game. If you compare that with, for example, with the afforestation projects, improved forest management involves a high level of complexity because of the multitude of different sub-methodologies or practices involved, because of the risk related to the permanence and reversal. There's a spelling error there. And the question around the baselines. And then, of course, the financial feasibility of these IFM projects. And then, from my point of view, maybe the topic that I really want to underline is the cost of MRV and the required accuracy of the MRV system applied. So we believe that, and I think it is well acknowledged, that digital MRV is really needed to strengthen the integrity, credibility, and scalability of improved forest management. That is to strengthen the carbon measurement with continuous and high-resolution data, improve the permanence tracking and reversal monitoring and detection, and in order to increase the transparency and trust through secure digital records. Moreover, scalability of high accuracy biomass and biodiversity measurement is needed, and then we really radically need to decrease the cost of MRV and the risk of human error. I will briefly present the project that we are working at LULUCF. This is Digital Forest Carbon Twins, a Business Finland funded research to business project. The aim is to develop a precision forestry and digital twin platform, including a use case for carbon farming, digital MRV, focusing on afforestation and improved forest management. This platform and the solution is designed based on the guidance from the technical guidance from the Carbon Markets Infrastructure Group. You may recognize that, so we want to make sure that we align with that. And then, of course, ensure compatibility with the relevant standards, including Verra VM45 and then CRCF methodologies. The core data architecture in this solution builds on drone and using drones, LiDAR and photogrammic imaging, in the data collection and data fusion with satellite data. So I want to emphasize our approach is direct measurement, not modeling or approximation. We then use AI-based algorithms in the, or the artificial intelligence advanced language models in the algorithm development for dynamic point cloud optimization. So when we run the drones, so we determine the optimal frequency for the point cloud. Then in doing the volumetric measurement, also we aim to identify and measure the deadwood in the forest. We are running pilots on this. And then, of course, most importantly, to be able to simulate different intervention scenarios to project the additional carbon accumulation. And then it's a no-brainer to do this all in blockchain to secure audit trail, transparency, and integrity of the project documentation. So this is basically a digital replica of the forest ecosystem, and our initial focus is on boreal forest. And to unpack this for you guys, so maybe to sum it up, it basically is moving from stand or parcel level resource planning to an individual tree level planning. These are some of the key capabilities and performance targets that we have determined. We use the UAV LiDAR data collection up to 5,000 data points per square meter. And just to give you a reference point, in Finland, the open forest data where the airborne data collection currently lands somewhere at 5 data points per square meter, giving approximately 10% margin error in the volumetric data. We focus purely on the above ground biomass, again, direct measurement. We then create the digital twin of the forest ecosystem with the key metrics, including tree species, breast height, meters, and et cetera, and then also then distribution of different metrics on stand level. Our target is to achieve less than 3% margin error on the volumetric data prior to the carbon conversion. We also have means using resistograph sampling to refine that carbon conversion also. And again, so this biodiversity, regarding the biodiversity, this deadwood detection, because it is a very key habitat for species in Finland, so it is an important biodiversity metric where we can use our technology to detect and measure the amount of dead wood per hectare. Now I need to speed up. Intervention simulation, spacing optimization, we use competition analysis. Of course, we want to plan for interoperability regarding the forest operations. That is something that we are baking in. And then this is not written in stone, but maybe just give you some idea. We aim at about 40 euros per hectare per inventory cycle on a scale of 1,000 hectares per day, if that gives you an idea. We are currently conducting pilots, collecting data. We've built a prototype. We are in a technical readiness level of 6 currently, and the aim is to spin off this technology from LULUCF and establish a startup towards the end of this year. This is some of the maybe visuals around, and not maybe the best quality, but that gives you an idea. So here only the visual presentation of stem detection, the species identification, the breast height diameter for each of the stems, and then the forest structure. So unfortunately, I was thinking of maybe organizing a demonstration of, but these are very heavy data files, so I gave up that idea. So hopefully this gives you an idea. And then very briefly, we also have a sister project, which is Interreg Forest Carbon Vision, where we are deploying the living lab methods to drive climate resilient communities. Innovation meets tradition is one of the keywords there, and transnational impact. So partners in Ireland, Green Skibbereen, and the Agriculture University of Iceland participating among the others. And here we also then test the technology that we are developing through different demonstration sites for carbon farming. So my time is up. I want to thank you, and for those who are keen to learn more or see collaboration opportunities, so please feel free to reach out. Thank you.
Thank you very much, Ville. So we are running after time, but we are going to have a short panel discussion. George is going to moderate this session. So George McLaughlin, sorry if I mispronounce again. George works for Climate Kick, which has already been introduced. He works across climate smart forest management, wood use, and circular bioeconomy in the built environment. So George, your challenge will be to moderate the panel discussion and to try to keep time to have exchange with the audience.
Thanks. Yeah, actually, quick question before I start. How hungry are you for questions? Before any questions, put your hands up if you have a question. Oh, so only one. So maybe the panel's, oh, 2, 3. Okay, it's all popping up. Okay, so there are a lot of questions. We did originally have 45 minutes for this, so we've now got half an hour. So we'll whip through the panel discussion, and then we'll see if we have enough time. Okay, great. I don't know if I'm going to stand or sit, so I'll just probably walk around, and then I'll hand you the various microphones as and when it feels right. So, yeah, that was an interesting coverage there of improved forest management approaches, economic modeling, and planning for the cost-benefit analysis, and then obviously the MRV discussion. So we're going to try and cover as many of these questions in the panel. So the first question, and this is directed to all of you, so whoever gets there first can answer. What is the potential for improved forest management in the whole of Europe? What practices, what barriers, and enabling conditions? Quite a broad question, but yeah, whoever would like to start. Maybe I'll prompt it with a thing. So based on your improved forest management work, so I'm looking particularly at Swasik and Vincenz, how applicable do you think it is to the rest of Europe rather than your specific geographic case?
Well, I can comment on that. And I basically now refer to the also the market data. So as we know, core carbon principle aligned standards like Verra are now gaining traction in the other side of the Atlantic. There seems to be increasing demand for IFM-based credits. But this, of course, is only for high quality. And of course, for us, then also CRCF is the way to secure that quality component there as well. But I would say that this is because of the fact that, it is so diverse. I mean, we have the temperate forest in Central Europe, we have the boreal forest in Finland, and in the Nordics, basically dominated by three species. It's completely different. The ecology is so different in Central Europe and Southern Europe than comparing to the boreal forest. So, but I see that if I would have one wish, then with regards to the development of the IFM methodology is to basically create the incentive mechanism. I'm now talking in the boreal forest context, to give the incentive for the forest owners to extend their rotations, for example, by 7 years, because you have, even if it's not financially super lucrative, you have the substantial biodiversity co-benefits with the older age structure in the forest. So it is kind of like an incentive that will not be a silver bullet, but surely would be a good vehicle to drive this type of change. All right.
To me, there is room, but there is need for safeguards. The first one is to prove that there is a real carbon gain, so that is additional. It's not true in some cases. And the other one is how do we handle the growing risk on forests? So we were talking just before about existing forest and the risk of wind breakage and the wildfires. We had one this summer in France, and it wiped out thousands of hectares. And we cannot predict them for sure. So how do we handle that? And the last thing is that we have an impending IFM methodology in France for irregular management, and the need for this methodology is not really for the carbon, but to finance the transition from regular management and a clear fell replanting system to irregular management, because the income for the forest owner is not at the same time scale. So this is where the need is for the forest owners.
Okay, to make it very quick, we are not a fan of standardized baselines because we believe that diverse and complex systems like the forests we have in Central Europe, they have real problems with standardized baselines. So we're using specific high quality data, and this is basically the requirement for our methodology. It works very well already in Austria and neighboring countries. There are some countries, however, in Europe where this data is not available. So there our methodology would have problems, but we made this decision that in order to have a very, very good, strong baseline, we need to represent the actual forest that is doing the project, and for that we need the detailed data that we're using. So wherever we can use that principle, we can apply our methodology.
Great, thanks very much. So I think also possibly related to that, it's a bit of a prompt for the next question is, what do you think of dynamic baselines then for Europe? What's the opinion on that, based on the fact that you're using kind of project-specific NFI data, kind of semi-standardized? What do you think of dynamic?
I think I echo here what Vincenz was saying, that, also not maybe a big fan of this dynamic baseline approach, what currently is now being baked into the Verra VM45 standard. But again, here the countries differ so much, and I think, of course, in Finland we have very robust growth models and basically a forest classification system that gives a very good baseline, but I still would opt for actually having controlled plots basically to really determine and build that trust into the baseline use, because here this, of course, countries, like I said, countries vary quite a bit here, what sort of national inventory data is available, and therefore we should account for that fact.
Yeah, I mean, the idea of dynamic baselines sounds fantastic, and in general I'm a big fan of doing anything possible to make the baseline more robust. But we are currently in Austria, we are struggling to find the proper NFI data plots that would actually fit to the forest that we're talking about, because the forests are so diverse, and it doesn't give me any additional information if I end up with 7 plots in Austria that would mirror the forest that I'm currently looking at. So we have to be very careful that this marketing idea, which it is to a certain extent on the buyer side, is not wrecking a good baseline. So in cases where we have a very good solid baseline and the dynamic aspects are not giving you any quality benefits, I'm a bit skeptical. However, our methodology, our baseline, project-based, has a lot of dynamic aspects in itself, which I think is important. You cannot start at the year 1 and pretend that in the year 30, the forest and the baseline that you're assuming right now will stay the same. That's not very smart, to be diplomatic, but I'm skeptical. If you give me the right data, if you give me the tools, I'm happy to use dynamic baselines. I don't have them right now.
Thanks very much. Okay, so moving on, I'm just looking at keeping an eye on the time. So we have we had a question around incentivizing resilient forest management, which I think we've briefly covered. But I think a specific question to you, Swazik, is does your NFI model break in even-aged, perhaps Scandinavian or Mediterranean forests, or do you think that it might work everywhere? Oh, is there oh, I can't hear that. Is there a reverber? Maybe I can speak loudly without the microphone. So does your model work in even-aged Scandinavian forests? Can it work everywhere, or do you find that it would just work in your case?
I think it can be calibrated for...
Take the mic for the people online, please. Sorry.
Oh, okay, for the people online, okay.
The model is, there are basic equations behind the model, so those can be used on any forest. And since it's calibrated for the allometric equations with national forest inventory data, as long as they are as qualitative as the one we have in France, it will work. So yeah, you just need to have like an equivalent NFI sampling.
Thanks very much. Okay, yeah, I'm going to move on to a different part now, which is Martina. This is predominantly directed at you. So how do we manage the time lag between investment needs and carbon revenues arriving decades later? So who bridges the gap for small forest owners, etc.?
Yes, okay. It's a very interesting question, and the problem that, I mean, the regulatory framework in Italy establishes that carbon credit can be issued and sold after the 5th year and every 5 years. So carbon credit, because it is the time needed to generate measurable amounts of carbon removals, and another key aspect is certification, because carbon credit cannot be sold without a verification process and certification. And the certification process itself takes place every 5 years. So in order to fill this time lag, this gap, an additional source of income could be represented by timber, no? But in the case of sustainable forest management project. And yes, forest owners could continue to carry out the harvesting activities in a sustainable way to generate the timber for the market. But in this concept, especially for Italy, in my opinion, carbon credit project can represent a real opportunity to recover the abandonments, the land in Italy, in Europe in general, and for relaunching the entire forest sector, but also for relaunching the silvicultural sector in Italy, in all ecosystem services that forests can provide not only for the market, but also for the collectivity.
Quick question to add on top of that is, so you presented your research as almost a kind of dichotomy between either harvesting for timber or carbon credits. Have you also looked at the potential of carbon stored within long-lived wood products? So essentially, a harvesting being part of an equation of carbon crediting, which is a part of the CRCF, which Simon was talking about. Potentially there's a piece there. I know it's in the label back carbon. There's an element to that. Have you thought about that in the modeling? Maybe I'm setting you up here, I apologize.
We are at the beginning of the research, as you can see by the presentation, but we will simulate 3 different scenarios. One scenario where we will assess only the production of timber, the general case without carbon credits. Another scenario where we will simulate the revenues from carbon credit selling. And the last one scenario where we will hypothesize a combination between carbon credit and timber. but we don't know the result we'll obtain, and it's research.
Yeah, exactly. Okay.
Okay.
Do you want to add?
Yeah, maybe just taking one example I mentioned earlier. So in boreal forest, we've done some calculations on this type of a rotation extension or harvesting delay by 7 years in a spruce-dominated stand. And basically going through the calculation, running the simulations, it is quite apparent that, you know, it is when you deduct the cost of MRV, the risk buffer, and then compare the net present value of the target compared to the regular shortened rotation, the delta is quite marginal. I think it is the cost of capital, or the weighted average cost of capital, that is the cost for the forest owner that he needs to think about. Ideally, carbon farming through rotation extension offers this incentive to extend the rotation, like I made my case before.
Thanks very much. And in many ways, you kind of answered the question I was going to be asking you in a second. So we would normally have a bit more time to debate, but actually I'm just looking at the time and I want to make sure everyone gets their questions in. So it's now open, the floor's open. I'll come and pass you the microphone. And could you even introduce yourself and the organization? Thank you.
Thanks. Hi, everyone. First of all, thanks for the fantastic presentations. My name is Farid. I'm a founder and CEO of Oxo Earth Technologies. We're a project developer for IFM credits out of Munich. And I have a question for Luke, I think it was. Yes. How do you get to 40 euros per hectare when you're using drones and LiDAR? I'd be really intrigued to learn what drones you're using, what type of LiDAR scanners, because that's, of course, the holy grail and a great project.
Can you stand at the panel table? Thanks.
First disclaimer I have to make is we are going through a patent process, so it's only a limited amount of information that I can share on the technical specifications. But of course, we know that the big challenge is the canopy penetration. We're using Gaussian splat to fill some of the data gaps. We're using agile sensor-equipped drones then to fill some of the data gaps. And then, of course, if needed, we can use terrestrial laser, but you know, then the cost goes through the roof, so it's not ideal. Now, the question around the cost, so it's just amazing how fast these drone technologies are developing. I mean, the equipment that we currently use allows us, I mean, we can do basically 500 hectares a day with the latest drones available, and we haven't yet tested these. The step up, the uplift in the productivity is substantial. But the calculation behind this 40%, again, I underline, this is more of a performance target. And of course, I mean, it would require uniform big area basically to be covered at one go. So you can optimize the locations where you operate the drone from, and et cetera, et cetera. So that's the sort of target. But then in reality, of course, I mean, doing smaller scale, you have to operate the drone from several sites, that the cost, of course, increases. But this is something that, you know, in terms of the pricing, once we get there, we, of course, have to do the pricing on project basis. But all I can say is that high-speed drones, if it's playing sort of fairly mature stands, it's amazing the coverage that we can reach within 1 day of operations. Thank you.
Yeah, thank you. I'm Alexa Meyer-Bosse from Munich Re. We are in the risk area. We provide professional risk products, climate risk products, and my question would go to Swasik. Sorry. How do you model these climate risks? I mean, you mentioned for France the wildfire as well as the storms. Do you ingest them in the model in terms of a more mixed stand is more sustainable to these two perils, and how fast they can recover? Thank you.
So we took the easy way out in this methodology. So there is no assumption on climate risks and disturbances like wildfires and storm damage. But when you submit the project, you have to fill a risk report. And so there is a 10% buffer that is applied to any forest project per default. And this buffer is supposed to take into account wind damage, for example. And there is an additional buffer for wildfires. So depending on the region where your project is, the risk is higher or not. So south of France, very high. And if you go to the north, it's lower or maybe inexistent. And so we handle the risks through the buffer, but not through the baselines or the model.
Hello, my name is Davide Petanella. I'm professor of forest economics here at University of Padova, and also working for 84, spin-off of the university. And I was much positively influenced by the outcomes of your concrete project you were showing Vincent in Austria. And if I understood correctly, one of the last slides where you were presenting the with and without project development of carbon sequestration, in your project you have been able to sequester, to have a removal of 15, 20 tons in 10 years. Yes. And also I remember that you said that you were working with projects related to areas and enterprises of 500 hectares and more. In one way, I was comparing this number. I mean, 1.52 credits per hectare per year with the cost of monitoring. So I was wondering how is possible in your concrete practical experience to cover the cost with such a low productivity in terms of credits. And considering, of course, an average price of the credits is, I think, could be around 10, 20 euros per ton.
Okay, so our current prices are between 60 and 70 euro because of this influence we actually have on the forest, on the biodiversity aspects and so on. But the average outcome is actually lower than 1 ton per hectare per year. It highly depends on the forest. We have forests with 2, we have forests with 0.4 tons. So I would say the average is between 0.6 and 1 ton. So that's not a lot. So your question remains valid. And the real costs are not only MRV. We focus on the very expensive regular, but only every 8 or 10 years detailed inventory that we're doing, and we're waiting with open arms for anybody to give us a really good tool to measure our forests in Austria. But then please keep in mind we have like at least 2 or 3 levels of different vegetation, different species, different age classes, up to 15, 20 different species. They all have different climate dynamics, so we need proper data. At the moment, we don't have that, so we are using the data streams that are already in place that I explained to cover that. But the real costs, of course, are the costs of reshaping the forest, to set management practices that are not cost efficient by themselves, that at least, that of course give you some additional income or give you a more resilient forest in 50 years. But forest owners have to be able to pay for these measures right now, in this year or the next year. And this is where the money from the carbon credits comes into place. And without our carbon credits, these measures would not be able to be put on the ground. but it's a very, very important question. If we add costs like MRV costs on top of everything, then the ice gets very thin, we say in German. I don't know if that makes any sense in English, but this is a crucial question. And then you will suddenly have projects where the real impact on the forest is maybe much lower, but it's just cheaper to produce like 3 or 4 credits per year. But is that what we really want for the cost of resilience, for the cost of stability? And this is a very slippery slope. So for us, we cannot sell credits under 50 euro per ton. It wouldn't make any sense. It's not feasible. 10 euros, no chance. This is, I think, also a big difference to agri. We have minimum costs, and we also have to give landowners the costs of the timber that they are not harvesting. And there you immediately end up at least 30 euro. So I would even question forest projects that are called IFM projects that can run on $15 in Europe. I would be happy to know their secrets.
Okay, thanks. So I'm Jerry Lawson. I'm a chartered forester from the UK, but I'm also the policy advisor for the UK Agroforestry Federation. So therefore I'm very interested in rotation lengths of trees on agricultural land, and we're worried that the 30-year maximum rotation period that's allowed there is not really enough. So I'm interested to hear about the move in France to move that to 40 years. In many ways it might have to be more. So my three questions. One, I haven't mentioned biochar yet. Do you see biochar as being an opportunity for early, previously uncommercial thinnings to become commercial, particularly if that is licensed as a permanent carbon removal, which seems likely at the moment? It could radically change the whole silviculture in Europe if we're able to use those early thinnings. Secondly, to what extent, we just heard that it's very difficult to include planning for fire, but coming from the agroforestry world, we're seeing more and more legislators including the option to move animals into forests. Previously in Central and Northern Europe, that was largely illegal. Now it's becoming more illegal. Even countries like Czechoslovakia are now allowing it to happen. A lot of the German lenders are doing that. That gives an opportunity to control the fire risk in fires. Can that be included within the models? Does it become a benefit? So I think that's the main thing. Can we change the silviculture in a way that is rewarded by more high quality timber coming out of the forest, but not on a 30-year rotation, on a 60-year rotation?
Well, maybe I can take on this one. So first on the biochar. So obviously you have to recognize this falls within the boundaries, not within the boundaries of carbon farming and the different methodology, but I do see, of course, potential with biochar. The challenge is that even if the biochar-based credits are being traded at the fairly high prices, it is a robust methodology as such, but the challenge there is that, what are the actual commodity end uses for biochar? Because I think that's just to use it to improve the soil quality, it doesn't really fly out. So there are certain challenges there. Yeah, and maybe agroforestry is not maybe something that I'm it's not very much in our focus, but I would only say that when it comes to the reversal risk and the permanence, I think the more data we have, the better forest management plans we can create to account for also to minimize that reversal risk, be that through different type of fire corridors and so forth. I mean, it basically is that, once we have the data, the simulation capabilities, for example, in our advocating for our platform, but this allows really to put weight on, for example, on the reversal risk, so to take extra measures to reduce that risk, for example. I think, as much as I have appreciation for the traditional expertise in forestry, but this data will really change everything. I mean, like I say, we will move from stand level resource planning to individual tree level planning. it is super data heavy, that's for sure. but if we get these ingredients correct, that really will open up enormous opportunities. And therefore, I would not only stick into looking just carbon farming, but more natural capital resource planning more broadly. Thank you.
Great, thanks. Unfortunately, if you have any additional questions, you're going to have to save that for lunch or other times. I just want to make sure we have a few minutes to conclude. I was trying to think of the best approach for concluding. Obviously, thank you all for your inputs. If any of you could put forward any recommendations from today that you think the EU should take into consideration with the CRCF preparations or methodologies that should be taken up by everyone, what might you recommend? I might give you a minute to think.
To me, for the CRCF, there is a need for a very clear framework. So nothing like super vague, and for the project developers to just understand their own way. And there is a need to put the cost of the MRV in front of the cost of the project. Because what we see in France, we used to have in forestry only one verification. So this makes for very, very low MRV costs. And the new methodologies demands more verifications, and we see that the price is going way up compared to the initial projects of afforestation and reforestation. And there is a growing fear from the investors and also the project developers that the demand is going to go down because of this. So there is a need to stay grounded in what can be done.
Okay, thank you very much. Any other final thoughts? Yeah, thank you, Martina.
Of course, resulting from this session, there isn't only one solution valid for everyone, no, because it's very important the coordination between several with people with different expertise, and in order to carry out a comparison and for exploring everything possible around this type of investment on economic return, but not only from an aspect of biodiversity, forest degradation, wildfire risk, and so on.
Great, thanks. I think I also wanted to quickly add that I think it's useful, the discussion as well around making it easier for forest owners or project developers to put in practice some of these things, some of whom might not necessarily be experts in carbon farming or carbon projects. So it's also good to see that all of your projects attempts to kind of simplify the process or make it easier for people. Any one final comment? Okay, yeah.
Just very briefly, because I think I've come across this through our Living Lab, also when consulting the stakeholders. I think, ultimately comes down to money, right? The financial incentives. And I think that, what really would be beneficial in building the capacity across the project developers and, most importantly, the landowners and forest owners, I would really see the value of having business case calculations demonstrating through different parameters that what is the upside for forest owner, what is the uncertainty with the different parameters that are used in different calculations. So I think this would be quite useful for many.
Great, thanks very much. Okay, so the final thing to say is if you're all still interested in forestry, there's still 4 more sessions to go before the end of the whole summit. So we've got 2 going on at exactly the same time today. So we might have to split and tell each other how it went. So C2, which is demystifying carbon forestry, forest versus agriculture, ? And then there's E3, which is monitoring and certification for forest carbon projects. Both of those sessions are happening at 4:15 today. So bear that in mind. And then tomorrow at 4:15, there's innovative financial models to scale carbon forestry. And finally, on Thursday, agroforestry, carbon farming, EU and Africa cooperation. Those are the most clear forestry elements, but there are also other MRV type sessions going on as well. So thank you very much for the speakers. It's really appreciated. A lot of your presentations are very interesting. I'm pretty sure that will be provided afterwards. The slides will be provided afterwards, so that will be useful. And the session, I believe, has been recorded, so if you missed anything, you can always go back. And that's the case for the other ones. So thank you all. Thanks.